Thank you everyone for being here. Here we are. Today we are going to have master thesis defense of Hiba Al-Kubaisi from the Department of Electrical and Computer Engineering. I would like to first thank you, the jury members, and a short introducing them. I will start with Prof. Adarsh. If we have your camera. Prof. Adarsh is a professor of civil engineering, and he graduated from Mumbai, Indian Institute of Technology, Mumbai. He is also associate editor of Journal of Aqua and Water Discover. Yes, Water Discover. And I have the honor of being his friend since about 1 month ago when I met him in China in a workshop that we were there. Okay, thank you, Prof. Adarsh, for being here. Prof. Jihad Hemare is head of the engineering and computer and electrical engineering department. Our colleague here, and he's a specialist in signal processing and telecommunication. Thank you, Prof. Jihad, for accepting being jury member. And our colleague also, Dr. Özgün Akderman. He's my 7 years friend here, and we collaborate together. He's expert in water resource engineering and also water quality, and with some specific expertise in GIS. Okay, now the turn is for Hiba Al-Kubaisi. He can share and start his defense, her defense. Thank you.
Hello everyone. I will start with Bismillah ar-Rahman ar-Rahim. Today I will be present my master thesis under the name of drought modeling and forecasting using emerging blending techniques. My name is Hiba Al-Kubaisi. I graduated from Al-Anbar University in Iraq. My presentation includes 6 chapters as shown here. First, introduction and objective. Second, literature review, and then methodology, and then study area and data, result and discussion, and finally conclusion and some suggestions. Drought is a hydrometeorological phenomenon occurring periodically impacts agriculture, economy, and human life directly and indirectly. Severity, length, and frequency influenced by watershed characteristics and water supply demands. Statement of the program visibility the potential advanced deep learning techniques to enhance drought forecasting accuracy. The study explored the potential of advanced deep learning techniques to enhance drought forecasting accuracy, addressing the limitation of conventional method by identifying complex nonlinear pattern and dependency with the climate data. We have 2 objectives in our research. Objective 1, developing an MLP model for month-ahead SPEI-6 forecasting. The objective 2 will be developing LSTM model for month-ahead SPEI-6 forecasting. This work demonstrates how deep learning algorithm can significantly enhance drought forecasting, thereby improve agricultural decision-making, resource allocated, and social preparedness. My presentation will be done for Iraq, and more information about the case study area will be given in this slide. Here we have a table. The first table will be about the drought monitoring studies, and the second table will be on drought forecasting. We have here Jassim and Auchi elevate Iraq's meteorological drought for 1970 to 2013, revealing recurring droughts, predominantly mild, with the most severe between 1997 to 2001 and 2007 to 2010, and North Stain zone most effective. About drought forecasting, here we have Al-Khatami et al. 2023 developed a high accurate rainfall forecasting techniques for South Iraq marshes using optimized hybrid CNN BDLSTM deep learning model. Also, there are many studies in a country like this, but because of a short age of time, I want to mention just Auchi and Jason and Auchi 2020 monitoring study, and Nasser and Hamdan 2021 for drought forecasting. Machine learning. Machine learning is a type of artificial intelligence that enables a system to learn from data instead of being explicitly programmed. It involves the use of various techniques that learn from information to decrypt data, predicted outcome, and enhance performance. By training algorithm with the data, machine learning method can created with which can then be used making a prediction or decision based on a new information data, input data. How do we implement machine learning? First, we need to data collection, then data pre-processing, choosing the right model, training the model, evaluate the model, hyperparameter tuning and optimizing, and finally forecasting and implementation. Conventionally, machine learning are two types. The first one, supervised learning, and the second one, unsupervised learning. For supervised learning is a type of machine learning where the model is turned on the labeled data, meaning that each training example is paired with an output label. The goal of the model to learn a relationship between the input data and the output label. It can predict output for a new unseen data. Supervised learning is commonly used for tasks such as classification and regression. For unsupervised learning, is a type of machine learning that deals with the unlabeled data, means that the model is not provided with explicit output label. Instead, the goal of this model is to identify the pattern, structure, or relationship within the data on its own. This type of learning uses tasks such as a clustering. Machine learning includes shallow learning and deep learning. For shallow learning, we have a single layer MLP. For general, MLP is a type of artificial neural network widely used in machine learning. It is designed to simulate how neurons work in the brain, processing the data through interconnected layer of node. MLP excels at tasks like classification and regression by learning a complex pattern for input data. Here we have a single layer MLP as shown in the figure. About deep learning, deep learning in general. Deep learning is a subfile of machine learning that uses a complex multi-layer artificial neural network to learn from data. Deep learning is good for complex phenomena like a drought in a climate change station. For deep learning, we have a two-layer, for example, we have two-layer MLP and LSTM methods. For LSTM method is a type of advanced recurrent neural network RNN designed to handle a sequence by eventually capturing long-term dependencies. It used a gate to control the flow of information, allowed to retain and utilize information over extended sequence of data. LSTM excel a task like predicting a sequence in a time series, text analysis, and speech recognition. We have two common metrics for evaluating predicted model performance. First one is Riemann square error, and the second Nash Sutcliffe efficiency. Riemann square error quantifies the average division between the predicted value of a statistical method and corresponding actual value. And for NSE, is metric used primarily in hydrologic to assess the predictive power of the model. It ranges from negative infinity to 1 or positive infinity. We have a study covered 3 cities of Iraq that show in the figure. The climate of these cities are similar. Each of the 3 locations, they had a very hot summer with a temperature ranging from 42 degrees Celsius to 48 degrees Celsius on average. A global SPE data. The SPE is multi-scalar probabilistic meteorological drought index. It has been widely used in many studies. It considers variation in both precipitation and temperature, and therefore correlates better with the hydrological and ecological variable. Here, the data preparing and optimizing selection. For data preparing, the worldwide SPEI database, which provides long-term SPE shares at a global scale with a geographical resolution of 0.5, was used to get monthly SPEI data for Baghdad and Babel and Irkut in Iraq. Optimum impulse selection. In optimum impulse selection, we use MI, mutual information, and percent correlation, often sent CC, are static metrics used to evaluate the relationship between two variables. MI quantify the overall information shared between variables, regardless of whether the relationship linear or not. On the other hand, CC measure the magnitude and direction of linear correlation. Both of them used to analyze the correlation between the SPEI and EI and other meteorological or environment factors. As I mentioned, I use MLP, one single hidden layer and two single hidden layer and LSTM model. And to do that, I use a Python package. And this is the result. The first result was for a single layer MLP model, 1 up to 10 neurons. I split the data into training and testing, 70% for training and 30% for testing. Calculate RMSE and NSE. Here, as we saw in the table, we note that the program did better with the more neurons, up to about 5 neurons. With 5 neurons, the error got smaller and the predicted become closer to real-world data for both training and testing. Here, these two time series are overlap. They cover each other. This model was acceptable. For scatter plot of 5 neurons for a single layer MLP model, the data distributed close to each other. We discovered that MLP neural network with the 5 neurons in one hidden layer was effective effective design for a predicted SPEI6. Here we have the result of a single layer MLP model up to 20 neurons. The model performs as the number of neurons increased up to 14. Both RMSE and NSE measure indicated higher accuracy and dependency. The model with 14 neurons achieved the best balance, resulting in the test RMSE of 0.3784 and a test NSE of 0.8411. For the time series, the figures show the single layer MLP with 14 neurons can capture the fluctuation pattern of the observed data. Here we see some high negative value. Some of this value is captured by MLP. Here, as we show a scatter plot of 14 neurons for single MLP model, 1 to 20 neurons, the data is distributed close to each other and close to the fit line. MLP neural network showed a strong capability to predict SPEI6 with the most effective model configuration consisting about 11 to 14 neurons, as shown here in the figure. Result of two hidden layer MLP model. Here we have the best value. It was in the 9 neurons in the first layer and the 6 neurons in the second layer, with the value for RMSE 0.4164 and NSE 0.7871 for testing. We note that the model had a smaller number of neurons, often show a greater RMSE and lower NSE, which suggests that their performance was the worst. In constant step up with the excessive number of the neurons often result is in overfitting. The model exhibited exchange execution of the training data, but performing badly on the test data. And the time series is what events that the value closely aligned with the actual event, hence provide additional validation of the model effectiveness. For scatter plot, the actual outcome and observed outcome showed the data was distributed close to each other, and it was close to the fit line. For the box plot of RMSE and NSE, compare the result. demonstrates constant performance throughout the training and testing stage. The results research show that MLB neural network with a two hidden layer can accurately predict SPEI6, and that accuracy of the model may be greatly increased by choosing the optimum neurons configuration. Result of LSTM model. The LSTM model was built with 15 units in the LSTM layer, followed by dense layer with a single unit, as shown here in the table. It was then complied using the Adam optimizer and meant where error loss function. The model underwent training for 50 ECOPs with a batch size of 1, running the respectable level of confidence. The model predictability was assessed using two primary metrics, RMSE and NSE. The findings show the training RMSE of 0.3631 and a test RMSE 0.3950 indicate that and the model has a capability to forecast SPEI 6 value. The NSE value for the training and set and testing set were 0.80 for 27 and 0.7881 indicate a specific significant level of predicted accuracy and dependency. The time series plot evaluate the value. It was we have a two-time series here aligned. We have observation outcome aligned to forecasting value, hence provide additional validate of the model effective. Here for the scatter plot for training and testing, the value was acceptable. It was distributed close to each other and close to the idle line. For box plot, for RMSE and NSE, confirmed this result demonstrate starting a constant performance throughout the training and testing stage. For discussion and conclusion, first I'll be evaluate of MLB model. For MLB model 1 up to 10 neurons, this pattern highlights the significance of choosing the ideal number of neurons to strike computing with the model complexity and performance. When we increase to 20, the outcome underscore and exceeding the specific and the number of neurons might result in declining result and overfitting, underscore the need of metrical hypermetering optimizing for two hidden layer 1 up to 10. This outcome underscore that extending the specific threshold and the number of neuron might result in declining result or an overfitting. Underscore the result of metrical hyperparameter optimization. For LSTM model, the fine suggestion the LSTM model successfully catch the time dependency pattern in the data and predict dependable predictions. For conclusion, we have the result for MLB model achieved an RMSE of 0.3784 and an SE of 0.8411 on the test set. An LSTM model achieved an RMSE of 0.3950 and an SE of 0.7871 on the test set. When comparing the MLB and LSTM model, the research initially used a single hidden layer MLP model, varying the number of neurons from 1 to 10. We found the performance improved, a lower RMSE and a greater NSE. The number on the five neurons. After that, after we increased the number up to 20, we attend with the maximum effectively was attained with 14 neurons. Adding the second hidden layer 9 neurons in the first layer and 6 neurons, and the second predicted the greatest result. Despite the advantage capabilities of LSTM model in the capturing long dependency and temporal correlation, the shallow MLP model with the 14 hidden neurons slightly outperforms both the deep TMLP and LSTM model, and in terms of RMSE and NSE for given SPEI6 prediction. This suggests that the simple MLB model is more effective for SPEI6 modeling in this study. In the study area due to the specific data length and characteristics. And for future suggestion, other type of deep learning model can be testing or maybe extend this study for entire Iraq. My thesis was limited to place called Karbala. I suggest that LSTM or MLB or any other deep learning model can be used for a drought forecasting for entire country. Thank you.
Good. Thank you.
Okay, thank you, Hiba, for your presentation.
Thank you so much.
Now, I would like to ask our external jury member, Prof. Adarsh. If you hear me, please, you start with some comments, your opinion about the presentation.
Yeah. Is it audible?
Yeah, we hear you. Please continue.
Okay, fine. Okay, thank you, Hiba. A good presentation. I have a few clarifications on the work. So I think you have predicted SPEI. You forecasted SPEI based on 3 methods, right? MLP. Then
Yeah,
MLP
based on
with two layers, and then LSTM.
Yes,
you
are
like
right.
that?
Yeah, it's like that.
I think her video, this audio.
Yes,
muted. Her audio is muted.
We hear. Continue. Yes, as you told, I just repeat. He says that you first use MLP, then second layer, and then LSTM.
Okay. Then finally, that you are concluding that MLP is performing best in the last slide, right? MLP is performing the best. So you, what about the MLP with 2 layer? MLP with 2 layer model or MLP with a single layer performs better? That you didn't mention. Hello, Professor Meher.
Yeah,
I
yeah,
think
we hear you. Yeah. MLP with one single layer performed better than two layer. Yeah, she says like that.
Oh, okay. Well, so single layer performs than two layer also, and also LSTM.
Exactly, yes.
Oh, okay, fine. Okay, then you have tested with SPEI 6. Okay, so what about the other drought index like SPEI 3 or SPEI 12? If you use, what do you expect?
He says that.
SPEI?
Yeah.
The pause is not clear for me because
Yeah, he asked that you run your model for SPI 6, but if you use for SPI 3 or SPI 12, what can happen? What's your expectation? Continue.
My expectation will be maybe we will have maybe not like this model that it will not run eventually not for others. Maybe run eventually, but SPI 6 will be the result will be maybe actually we run for SPI 3, but the result was not better than SPI 6. So we just select SPI 6.
Can you please repeat?
Yeah, let me repeat because I'm closer to computer. She said that she already did the same task for SPI 3 and she got worse results than SPI 6. So her experience said that these models should be improved to be able to apply to the prediction of SPI 3. But for SPI 12, she didn't have any experience, any opinion. If you use for SPI 6, do you think that your model will be better or worse?
Better, I think. Yeah, it will be better.
Yeah.
Yes.
Yeah, because LSTM or deep may be working well for more complex like SPA 3 or like that. That type of that can be another suggestion. You can scope for future study. You can write because the complexity is different for 3 or 12 or 6. Maybe 3 may be more complex. Some more algorithms you mentioned in the slide, like other deep learning models you can test.
Yes.
So like that, you can test for the different SPA, like SPA 3 or SPA 12, like that. Their complexity will be different. You can investigate. That can be another way to do that. Okay. Then another thing is you have forecasted for some period, some 250 plus months, like maybe 10-year data, 10-year, nearly 10-year you might have forecasted, right? In slide
About testing period.
Slide 21.
Go to slide 21. Just a minute. He asked you predicted for 10 years or what's your
Maybe,
testing data period?
20.
6 months.
20.
30%.
30% of data was for testing. Okay, it is how many months? How many data you had?
20, a slide just previous.
9.
Slide 20.
Yes, works.
Yeah, so nearly 250 plus data. So what I am asking is this 250 data, is it different from that of training? Testing? You are forecasting completely different set? Are you forecasting for a completely different set or not?
Are you forecasting completely different set for testing or they are the same with training. Yeah, he asked like this. He wants to be sure that you separated the data completely or not. Okay, answer please.
Training and 30% for testing in my model.
Yeah, she says that the model was trained with only with train part, and the testing part was unseen. Before, during training, the testing data was considered as the unseen data sets. In other words, technically, she didn't do cross validation, just train and test.
Fine. What I was asking is the forecasting means, is it this forecasting is different from testing, or is it the same as testing data? You mentioned as modeling and forecasting in the title.
Yeah. Outcome forecast. Yeah, it was the same. Actually, by modeling or forecasting, the forecasting here, she means by forecasting, she means the task. The testing part is the part that actually
Used as
forecasted.
forecasting. Okay. I thought it may be different, separate set of data she forecasted after modeling, after training testing combination. She used a completely different set kept us for forecasting. That is what I was clarifying.
No, it was not like that.
It was no, because in the title it was modeling and forecasting. So I got that thing. Then,
sorry, Professor, the title of this figure or the title of the thesis? The thesis?
Thesis.
Yeah. Yeah. What? For modeling and forecasting. Yeah, we correct the title. Yeah, Professor, if you have some suggestion for revising the title to make it more clear, you can suggest and we can apply that to revise the title of test.
Okay, if possible, according to your rule, you can do, but I suggest, if possible, modeling can be removed. That's enough, because top forecasting, that will be enough.
Okay, thank you.
Yeah, then this last probably one is regarding the selection of the variable. You used mutual information and correlation.
Yes.
Right. So
Yes.
from the two sets, how you fixed the inputs, two types of methods.
Yeah. Okay, he said
how you arrived at the input set. I think there is a slide also. I think 10.
Just go to slide 10. Okay, Professor. Okay. He said that you used cross correlation.
Yes.
And mutual information. Finally, which one you used to select the inputs? He asked that.
For SPI6, we select NMI, mutual information, which was from
mutual information was finally selected.
Yes.
Oh, okay. So from this diagram, which you selected, which lags you selected, maybe how you fixed the threshold, which are the variable influential, maybe 1, 2, 3, 4, 5, something like that.
We select 6 and 8 and 9 and 11.
But 9 and 11. So how actually you picked that specific 9 or 11? How you are selected that? From these values, how you picked that specific 9 or 11 or 6 or 3? How
Okay,
you
answer. He said that, okay, you said that you also selected 9 and 10.
Yes.
What was your criteria? Why you
Yeah,
also selected
exactly.
9? Why you selected 10? Why not up to 5? Professor Adash, based on the figure,
Yes.
it seems that 1, 2, 3, 4, and 5 lakh can be enough. But you said that you also selected 7, 9, 10, and 12 maybe. Which one do you say?
Select one before. Select the minimum lakhs here.
Can you show us our input, your input data in your models?
Yes.
Professor, let's see the model inputs, which lags.
Yeah, fine, fine. Yeah.
Yeah. Show them.
Lag 12, 5, 4, 3. Okay, 1 to 4. Okay, 1 to okay, 1 to
1 to 5
and
and
then
12.
12 month. So 12 month maybe one cycle before.
Yeah,
Last
exactly.
year.
Exactly. The
Oh,
12
fine.
shows the cycle, and from 1 to 5 shows the higher mutual information value.
Okay, okay, fine. Yeah, okay. Hiba, no, don't get tensed. Okay, so this is just an exercise. So the last question is on your model, that two methods. You mentioned LSTM and MLP, and I think there are two. You mentioned the parameters of LSTM, like dense. You mentioned somewhere, I think, parameters of LSTM.
What are the parameters of LSTM? Dense, you showed dense.
What you can you show that slide 50?
Go to
That
the
slide,
LSTM.
I think 19, 19. Yeah, here this is what LSTM and 50 and neuron number of neuron is 50. What do you mean by dense structure? How you
The structure was
consider it as dense structure of LSTM?
Sorry, Professor, could you please repeat your question?
How you are saying it as a dense structure
Why you say this
of
is dense?
LSTM? Why you said it as dense?
the first layer, it was a 50, and the second.
He asked why the structure name for this two layer is dense. Why it is not LSTM? Yes, why it is dense?
Because it is dense.
Because of having two layer,
Yes.
it is called dense.
Yeah.
Is it-
the end? Yeah. That and one, the last one, dense.
Only because of two layers.
Yeah, we have the two layers because of that. The first one was LSTM, and the second one was the dense.
Dense. Did you hear?
No, can you please repeat?
Yeah.
Anyone of?
He says that because of having two layers, it is called dense.
Oh, okay. Because of two layers, means LSTM having two layers. LSTM has two layers. Because of that, it is called as a dense architecture. Is it like that?
She says yes.
Okay. So NSC you mentioned, how it ranges actually? What is the range of this NSC, Nat Sutcliffe efficiency?
What's the range of NSE? How NSE varies, minimum, maximum.
It's the range from negative infinity to negative positive infinity to 1.
From
Minus infinity to 1. Okay,
yeah.
fine.
Fine.
Okay, I think that is enough from my side.
Thank you so much.
Hiba, yeah, yeah, all the best. I'm giving it to my colleague. Okay.
Thank you, Professor. Thank you so much for your comments.
Yeah.
Okay, let's ask from internal jury. Prof. Cihat Emre, I have some questions.
Okay. Thank you, Hiba, for your presentation.
Comments, or you can call them suggestions. So slide number 4, we are showing the literature. Really surveys of the story. Surveys. I found 2 surveys just studying what people have done to solve this problem using deep learning algorithms. So I believe this literature needs to be improved more. You need to add more references. And more importantly, you need to compare your results with what other people have achieved. Okay. For example, you could say that in reference X, they did this and they got this result. In reference Y, they did this and they got this result. How do my results compare to these results? So you could do this to improve your literature review, because at the end of the day, you are aiming or targeting a conference paper. You might want to publish this so that you can put it in your CV and strengthen your PhD application in the future. So this is very critical. If you don't clarify how you are different from the other studies, it's very difficult to get your paper accepted. This is just considered as a humble suggestion to improve your study and make sure that it will be accepted. So this is very critical point. I can also send you an email about these references that you need to include and compare with. The second suggestion, you can go to MLP slide number, in which you showed that at neuron 14 you got the best result, and then after that you didn't get any improvement.
Table of MLP.
Here, for example, you got the best result at 5, and then after that you didn't get any improvement, but you didn't explain this. Why do you think this happens? Like, it means that you don't need to go to 6, 7, 8, 9, 10. Up to 5 is 5 neurons gives you the best result, although it's not a good result. Like RSME 0.4 is not really very good. Like this, if you translate it to accuracy, this means this model has 60% accuracy, which is not really great thing.
But it's acceptable.
Yeah, it's but why do you think at 5? I'm not gonna argue about the accuracy. I will say something.
Why you selected 5?
Well, no, why do you think at 5 it gave me the best result, and after that it started improving? It gotten worse. You increase the neurons, but the performance is not improving. Why do you think this happens?
Actually, I selected depending on RMSA and NSA. So I think it may be overfitting.
Very good.
Yes.
Yes.
Yeah.
This is what I wanted to hear from you. It's overfitting when you are increasing the neurons, and necessarily you end up getting overfitting problem, and it tells you that adding more neurons will not improve your performance, but rather it will worsen it. And that's the answer. And you could add that. It's really nice explaining the results, explaining why did you get this. And last thing, maybe in the conclusion part, go to the slide of the conclusion. Here you showed that NLP gave you RMS of 4.37 and LSTM 4.391. I suggest you strongly, this is not a difficult job. I suggest you to add more models, compare them in terms of 3 metrics, 3 performance metrics. First, their accuracy, and sort them from the best to the lowest. And then in terms of complexity, which model has the highest complexity and which model has the lowest. And then in terms of latency, which one gives you the fastest result? Which one is the fastest? Which model gives you the result as fast as possible? So if you could add ShuttleNet, GoogleNet, these new emerging type of neural networks, they will give you, from one hand, much better performance, and from another hand, they will enrich your study and make the comparison much more meaningful and strengthen your study compared to the other existing studies out there in the future. So these are my 3 overall suggestions. I hope you can reflect them in your updated thesis version. Thank you.
Thank you.
Okay, thank you, Prof. Hemare, for your comments and suggestions. I just want to get more clear about the literature review. Actually, I asked Hiba to do literature review for Iraq. Maybe your studies cover entire world.
Literature review for Iran.
Yeah.
Yes, but like
because
you make it very specific.
because why we did it, because actually draft is hot topic.
Hot topic.
As on the other hand, AI is hottest one.
Deep learning is like,
Deep hot. So when and climate change is also hot. 3 hot topics connected in this thesis. So I'm sure that there are at least 1,000 papers after 2010 talking about draft globally. So because of this huge amount of data available online, we try to focus on Iraq to get more insight about the country situation. And this is why she focused, but we based.
You should have said this to distinguish, because at the end of the day, the reviewer will keep searching for that.
Yes.
How are you different from others?
Yeah.
You could say, I'm just focusing on this region, and I know there are thousands of studies done on this topic, but on this specific region, just we got these 5 references, but you still didn't compare with their results.
Yeah.
You compare with their results. You have to tell us what accuracy the authors have achieved and how the results compare to that.
Yeah, it will be done. Actually, it seems that the discussion section is weak based on if there is no comparison between the other studies, which definitely done for Iraq, because the different climate needs different models. For more arid area, definitely we need more complex models because of the signals. Signal feature change requires different models. So discussion definitely will be improved, and also we took the note that some global studies should be also reviewed and added to the literature review section. Thank you. Thank you, Professor. Dr. Özgün Akdermen. We are listening to your comments.
Thank you, Professor. So I have one small comment. Thank you for your presentation. When we are doing the presentations, as much as possible, we are trying to avoid showing the tables, right? In your tables, for example, you were showing that the 5 neurons are the best.
Because it can be recorded from here.
Okay.
We have.
So try next time when you are doing the presentation, probably you will be presenting this in a conference also. So if you just present it on a graph that is showing that the 5 neurons are the best, then NSC values decrease like this. So this is the better way that people grasp the idea, okay, 5 neurons are best, just rather than trying to read from the table. So it will be better. And thank you for your presentation. It's great.
Okay, thank you, Dr. Akderman. So I think we can ask students go out now, then we can discuss about your scores. You can move, stay outside. Yeah. Stay outside, then I will ask you to come to evaluate and to say the result of evaluation.